G'day again. Welcome back to Mathematics 302. Hope you're having a good morning or a good evening, as the case may be. This is our very last lecture for MAT 302, and this is 12, lecture 12 and part D. So I'm only going to go through four more things here in revision for the assessment. So let's get into them. God bless you. Pray you're studying well. Here we go. Question one. Determine if a series from 1 to infinity of 1 over n squared plus 1 converges or diverges using the integral test. So it doesn't matter which test we're going to use over the next few slides. Converges, if it goes to a number, any number, positive or negative, doesn't matter, then it converges. Otherwise, if it goes to infinity, it diverges. Pretty easy. So we're going to use the integral test, and there I've just said what's in green, which is we're just integrating whatever this is. And here we've just got 1 over x squared plus 1, just changing the n for an x because that's the typical thing to do when you're using an integral. The next typical thing to do is they change this infinity when they write limit into some random letter. We can change it into whatever random letter we want. I'll pick A, and you're just going from that to that. It really doesn't matter because ultimately you're going to put infinity back in. So we're just integrating this. In this instance, it's not something that comes to mind where you go, oh, what steps can I do? This is actually straight out of the formula sheet. So if you get a question like this where it's from the HSC standard formula sheet, then I will give you the formula. I'll either give you the whole formula sheet or I'll literally say this formula is for this equation to make it easy, so because I don't want you to waste time doing that. That's not the point of doing the test. So the integral of this is 10 to the minus 1x. So we've got 1 over x squared plus 1. That is the integral of this equation. The ones the number before the x can change, but as long as you've got, literally can get it back to something like 1 over x squared plus 1, you get 10 to the minus 1x, and it might be x on 2 or 2x or whatever. But for this one, very straightforward, and we want to go between 1 and a, where a is going to be infinity at some point. So we're going to go 10 to the minus 1a minus 10 to the minus 1, and now we're going to put in infinity into the a. Now, if we put infinity into the a, we're going to get 10 to the minus 1 where that 10 goes to infinity. If you look at a graph and just start drawing graphs which go like that, which are giant, giant S's, or what's another similarity to that is the y equals x cubed. So 10 is very similar to y equals x cubed. And at this point here, where you've got it going to infinity, that's typically pi on 2. Yeah, pi on 2, it doesn't exist. You can't do that on your calculator because you can't actually type in infinity in your calculator. It doesn't quite work that way. But that is 10 pi on 2, or 1090. And I've just left the 1 there, so you can see I'm doing one step at a time. Shift tan 1, you should know from your 45-degree triangle is 45 degrees, which is pi on 4. So now I've got 90 degrees, take away 45 degrees, or in terms of numbers, pi on 2 minus pi on 4 gives us pi on 4. So that is a number. And since we've got a number, then we're going to say it converges. Okay, hopefully pretty straightforward, obviously, except for knowing that off by heart, which I don't expect you to do. Question 2. Determine if the series n squared of n plus 2 to the power of 5n converges or diverges using the root test. So for the root test, what you want to do is find the biggest power, sorry, and then take that root. So the biggest power here is n. We're going to take the nth root. So we're going to use the limit of, as n approaching the infinity of root a to the n. So we're just going to divide that whole root by n. There's no other powers. That power here is a squared. This is n to the 1. We'll do this one first. So that wipes that out, and it just gets us 10, n to the 10, and then n plus 2 to the 5. So we want the limit as n approaches infinity. I can't be bothered figuring this out, and I don't really need to. All I'm going to say is this is n5, this is going to be 32, and I don't really care about what's in the middle. So I'm going to say I've got this thing here, and I'm going to divide by the highest power in the denominator. So the highest power in this denominator is going to be n to the 5. N to the 10 divided by n to the 5 is Actually, that should be a 5, shouldn't it? That should be n to the 5 up the top, because when you divide, you subtract powers. Whoops. Sorry, that should be an n to the 5 up the top. Slight mistake there. So anyway, we've got 1 plus 1 over n plus, I really don't care what, 32 over n to the 5. So that's telling the examiner, yes, I know I could expand this, but I can't really be bothered. But I know that this is all going to turn into 0 because this is the only thing I really care about, that I've got this going to 1. So now I'm going to end up with infinity. My apologies about the power there, but this will just be infinity over 1, and therefore it diverges. And that's really what's the most important thing. So minor error there. Next one, determine if the series 1 to infinity 2n over n factorial converges or diverges using the ratio test. Again, same thing. This time we're just going to use the ratio test. So the ratio test is a to the n plus 1 over a to the n. In other words, for example, like the second term over the first term. So you're doing like that sort of thing. Now we've got this division. What you're going to do is, because this is going to be a fraction, is you're going to do a to the n plus 1, and you're going to multiply it by that fraction inverted. So a to the n inverted to the minus 1. So this is really what you're going to do, not try and do this giant double fraction. So I'm just going to go this fraction on top of, like another fraction on top. So a to the n, which we already know, is 2 to the n over n factorial. A to the n plus 1 is 2 to the n plus 1 over n plus 1 factorial. So now I'm going to put this number on top of this number. No, I'm not. I'm actually going to do this. This number multiplied by this upside down. So there we go. So that's our ratio test. So now we simplify that by just looking at it and simplifying it algebraically. So when you're simplifying a fraction, you're going to cross things off. So you want to cross off this 2 to the n with something up here. You've got this 2 to the n plus 1. I'm going to grab that plus 1, move it in front. So then I'm going to have 2 multiplied by 2 to the n. I'm going to do the same thing when I look across here. This is n factorial. I'm going to take out plus 1. I'm going to take out n plus 1 multiplied by n factorial. So what I've got now is that. So I've taken out this plus 1, and that's 2. I've taken out n plus 1 out of this, because this is n plus 1 times n minus 1 times n minus 2, da, 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 da. But now I've got n plus 1 times n factorial. Now I can cross those off. So I've rewritten that up here, and now I can put in my ready slashes and go, right, the 2 to the n's are out of there, and so are these n factorials. You're gone as well. So they're all now 1s. So now I've got 2 times 1 times 1 over n plus 1 times 1, and there's a 1 on the bottom over there. Okay, so now it's a lot simpler to deal with. I've just left the 1s in there just for show, but you probably wouldn't write this step. You'd probably write the next step and skip all those 1s. So now you've got 2 over n, and I've just put the infinity in. 2 over infinity plus 1. It's really easy to see. That goes to 0. So since that goes to 0, which is a number, therefore it converges. Okay, pretty straightforward. Question 4, last question, very last question. Determine the spectral norm of x equals 2, 1, minus 3, minus 1. Just random selection there of a matrix. Just want to really know what the steps are. So calculate xt, x transpose. We're just going to swap the 1 and the minus 3. That's pretty easy. Then we're going to do a multiplication, x transpose x. So that matrix multiplied by the original. So 2 times 2 is 4, plus minus 3 times minus 3 is 9. 4 plus 9 is 13. 2 plus 3 is 5. And then 1 times 2 plus minus 1 times minus 3 is 5 again, which you would expect. And the last one, 1 plus minus 1 times minus 1, which is 2. And so we get this. This is our new. This is xtx. Now what we want to find here is the biggest eigenvalue. So to determine the eigenvalues, you're going to put in minus lambda. I mean, you can do the step, which is to multiply by I minus lambda, but the easiest way is just to put minus lambda for the diagonals. Now you're going to find the determinant, which is these two multiplied together minus these two multiplied together. So I should have written determinant here. And you just multiply this out. This will become a quadratic. So we're going to get 13 times 2 is 26. Minus 13 minus another 2 is minus 15. Minus times a minus is a plus lambda squared. And we've got minus 25. 5 times 5. I should have here written 5 times 5. So now I'm going to go 26, take away 25 is 1, so we'll end up with lambda squared minus 15 lambda plus 1. So we want to factorize that. We can't factorize it because 5 times 3 is 15, and 5 and 3, the smallest number I could get to is 2 or minus 2, so not going to work with a 1. So we have to use the quadratic equation, minus b plus or minus the square root of b squared minus 4ac all over 2a, and we're just using those values in there. You probably should know that one off by heart because you probably used it in class enough. I have. I don't know if you have, but you will. So simplifying that, you get 15 plus or minus the square root of 2 to 1 over 2. And we want the biggest one, so we really don't care about that minus because that's going to make it smaller. So I just want the positive, which is 14.93303. I don't actually want that. I want the square root. The spectral norm is the square root of the biggest lambda or the biggest eigenvalue, which, square root of that is 3.872. And that's the answer. So now what I've done, I've just done a little bit extra. I could check it using a similar result to the one norm. And the one norm, which you probably remember, not sure if you do, but you probably remember the one norm is really just the absolute values going across. So 2 plus 1 is 3, 3 plus 1 is 4. So the biggest number of that is 4, and it's pretty close to that. Now, saying this is similar, what I then did was another check, just so you're aware. Let's make a deliberate attempt to split the norms. So we're going to try and find the one norm and the spectral norm. I didn't go through the steps. I'm not going to go through the steps here for this one. I'm just going to tell you what it is. So lambda in this instance is 2002. The spectral norm is that, which is 141.443. If we add these up across, where the one norm is just going to be 101. So you can see there's a little bit more difference here, 101 to 141. But if we divide by a factor of 10, the comparison is 10 to 14. So it's still reasonably similar to it. Obviously, it's a bit different, but you can still say, yeah, okay, it's within range. It's not like, one is 1 and the other one is 10,000. There's not going to be that much of a change. Even here, we're trying desperately to smash the norms apart and give them completely different numbers. They are going to have some sort of similarity. Okay, that is it. God bless you. That is the last lecture. All the best in Assessment 3. Thank you for a great semester. I really appreciate it when you're finding little errors that help me improve being a lecturer. It is just such a blessing. I pray that when you're in classes, that students bless you in a similar way, that you can learn little things. Keep smiling. Enjoy the adventure of teaching. And if you have fun, your class will love being with you. God bless you. Just wish you all the best. Okay, bye.